Hello everyone. In today's class, let us try to understand the significance of phenyl group in neighboring group participation. Okay. So we shall see couple of examples. Okay. So the first example is this is your trio isomer of 3-phenyl 2-butyl tosylate. Okay, so this particular representation, it is a staggered, more stable staggered Sahas representation. Okay, so erythro and trio forms can only be recognized when you draw your Fisher projection formula. So when the similar groups they are present on the same side, it indicates that the isomer is erythro, and when the groups are on the opposite side, it indicates that the isomer is trio. So from the Fisher projection formula, we have written the Sahas representation so as to understand the efficient formation of intermediate. So what we are trying to do is, we are trying to carry out acetylysis reaction. So phenyl group which is in 1,2 position with respect to the leaving group. Okay, so the group can only function as a neighboring group. So that means the group can only offer its anchimeric assistance provided it is in adjacent position with respect to the leaving group. Okay, now once this product is formed, then it leads to the formation of intermediate. So this particular intermediate, it is known as phenonium ion intermediate. Once you have this particular intermediate, you need to understand that whether it is symmetric or whether it is unsymmetric in nature. Now if you look at the viewpoint of the substrate, okay, you can either view the molecule from your left hand side or you can view the molecule from your right hand side. So when you are viewing the molecule from the right hand side, these methyl groups are coming towards the observer. So when the methyl groups are coming towards the observer, what you can see is, so those groups which are coming towards the observer, they are designated as beta, and those groups which are going away from the observer, they are designated as alpha. So that means they are indicated by broken lines. Now when you try to imagine a mirror plane which passes vertically through the molecule, dividing into equal halves such that left half it becomes the mirror image of the right half. So this indicates that this particular phenonium ion intermediate, it is symmetric in nature. Now you can imagine the attack of nucleophile. So it can adopt pathway A, this can adopt. So when the nucleophile attacks at this particular carbon, so that means let us try to see that this is pathway A and this would be pathway B. So when it is attacking this particular carbon, the OAC group, it comes here. Hydrogen is written like this, methyl group is written like this. Then you are having the phenyl group, then you are having the hydrogen and you are having the methyl group. Then you are having this OAC group, hydrogen, methyl group, hydrogen, methyl group, and you are having the phenyl group. Okay. Now, so once this is formed, let us try to designate this as A and let us try to designate this as B. Now when you have this particular Sahas representations, some students they find it very easy, but some students they find it very difficult, because as per the observation, you are getting 96% of racemic mixture and 4% of erythro isomer. Now, how you can explain this particular observation? So, what I try to do is the structure A, which is the staggered form, I try to write it in the eclipsed form. Okay. Now, why I am writing it as eclipse form? So as to efficiently convert it into Fisher projection formula. So Fisher projection formula, it is the eclipse representation of the Sawhorse projection formula. So when I try to rearrange A, so I write both the methyl groups, they are coming below the plane. Then you have OAC, you have this hydrogen, then you are having this phenyl groups and you are having this hydrogen. Okay. So whenever you are writing the Fisher projection formula, please note that there should be longest chain of the carbon atoms. So that means this is your structure 1 which you try to get. Then when you have your B which you have written, you can convert it into the eclipsed representation. Then CH3, H, PH, OAC and H. So this you get it as structure 2. Okay. Now when you look at this particular structures carefully, it is very difficult for you to ascertain, because here the acetate group, it is present at 2 position, but in this particular structure we are having the acetate group present at 3 position. So in this case, what I try to do is, I try to carry out one symmetry operation by in-plane rotation around 180 degree. So when I carry out in-plane rotation at an angle of 180 degree, then I try to rewrite the structure. So what I get in this particular structure is that, okay, so in-plane rotation at an angle of 180 degree. So OAC group comes like this, my phenyl group comes like this, hydrogen comes like this, methyl group comes like this, and so how can you explain the in-plane rotation at an angle of 180 degree? So if you have this duster, I try to do it this way. So whatever that was present on top, it comes onto the bottom. So I'm not changing anything. So I'm just trying to do everything in a plane. Okay. So this particular thing, it is known as in-plane rotation, wherein the substituents which are present on there, so that means you get this particular structure. So you write structure 3. Now if you try to correlate structure 1 and structure 3, what you can see is, you can try inserting a mirror plane, and you can see that this particular one, it forms a mirror image relationship with structure 3. So when it is forming the mirror image relationship with structure 3, they indicate that they are enantiomeric pair. So that means equal proportion of each of them is formed. So one thing you should remember, why equal proportion of each of them is formed? Why you are not getting the enantiomerically pure structure? Because the intermediate being symmetric, there is equal probability of nucleophilic attack, which leads to 2 different structures. So that means when you get like this, so this indicates that you get 96% of the racemic mixture. So one thing is clear. So one way is by carrying out the in-plane rotation. Other way is, what you can do is, you can assign the configurations. So once when you try to assign the configuration, so when it forms an enantiomeric pair, the configuration of each of the asymmetric centers for one would be opposite for the other structure. So that particular thing you have to keep it in mind. So this represents your understanding. And now how can you account for 4% of the erythroisomer? Now imagine, in this case, let us try to say the substrate is the 3O form, that is 3-phenyl 2-butyl tosylate. So that means the tosyl group, it is present at 2 position. So this particular thing can only be imagined, okay, provided acetate, that is acetic acid, can attack the carbon atom, displacing of the leaving group from the side opposite to that of the leaving group. So when such displacement occurs, the reaction occurs via SN2 reaction pathway, leading to the formation of 4% erythroisomer. So this indicates the product ratio. So what you should understand is, the moment you have threoisomer, the product ratio is 96% of racemic mixture and 4% of erythroisomer. So question can be asked in this examination this way. Now that I have provided you the structure, you all would be provided the IUPAC nomenclature. So based on the IUPAC nomenclature, you are required to write the structure. And once you write the structure, you can very well explain your observation. Okay. So this is with respect to the threoisomer. Now let us try to focus our attention to the erythroisomer. So erythroisomer, the methyl group is like this. You have your hydrogen. So this is your erythroisomer. Okay. Now what happens is, when you try to write the structure of the intermediate phenolium ion, compare the intermediate phenolium ion in the form in this particular case with that of the threoisomer, what you can see in this particular case, the stereochemistry of methyl group here is alpha, whereas at this particular carbon it is beta. But whereas hydrogen here it is beta and the hydrogen here it is alpha. So even when you are trying to put symmetric the mirror plane, so what you find is there is no symmetry observed in case of this particular intermediate. So that means what you can see from this particular structure is the intermediate is unsymmetric. So now when this intermediate is formed, so this is A, this is A, and this is B, and this is B. Now when you have this particular intermediate, so acetate from the bottom, H methyl group, then phenyl group, H methyl group, OAC, methyl and hydrogen. So this is A, this is B. So the observation states that you get identical erythro products. Now in contrast to earlier example wherein we were getting 96% of racemic mixture, and here you are getting the identical erythro product. So let us try to account for the fact once again the way we had accounted earlier. So that means your structure A, you try to write it so as to convert it into Fisher projection formula. Let us try to write it in the form of eclipsed sawhorse representation. So this is your structure 1. HOAC, CH3, H and pH. So CH3, H, OAC, H and pH. So when you get this, now again it is difficult for you to understand that whether it is identical or not. So what I try to do is I try to carry out in plane rotation at an angle of 180 degree. So OAC, then phenyl, then hydrogen. So this is your structure 3. So what you can see is, if you try to compare your structure 1 and structure 2, as compared to earlier example, if I try to take my structure 3 and try to put it on structure 1, what you can see is, you are getting the images which are superimposable with respect to each other. So those things which are superimposable with respect to each other, they are known as identical products. Okay, and what you can see in this case, the two substituents present at each of the two positions, such as 2 and 3, they are present on the same side. So that means when the substituents are present on the same side, you get the what is known as erythro product. So this explains the difference in reactivity between the erythro and thioisomers for each of the substrates. And what you should remember is, in case of thioisomer, the intermediate phenonium ion formed is symmetric, but in this case you are getting the formation of unsymmetric phenonium ion. So thank you very much, students.